Hi everyone! After finding the limits by using the limit laws in the last video, we're going to discuss here the different strategies in finding the limits of a function. Alright, so from the previous examples in the last video, you can notice that because of the limit of the identity function, we end up substituting x by its value, which is k. Alright, and this method is known as the substitution method. And in substitution method, if you're going to get the limit of your function f as your x approaches the value k, then your limit will not be equal to L, but will be equal to the function itself and substitute x by its value or by its approaching value, which is equal to k. Alright? So, pwede naman palang ganyan, sir. Ba't kailangan pang pahabain? No? So, well, it's better to understand first the concept and the long method before we try to strategize a shortcut method of this concept. Alright? Well, not only in this concept, but also in the concepts of the other fields. Alright? Now, when we evaluate the limit, we simply substitute x by its value and simplify. Alright? So, let's start with an example. If we're going to get the limit of your raised to 2 minus 7 all over, let's say x plus 3, as your x approaches the value of 0. All right. So we have here a rational function, and we're going to use the substitution method in order for us to get the limit of this limit problem. All right. So we have here, by applying the substitution method, this will become 0 squared minus 7 all over 0 plus 3. Alright, as you can see, we're just substituting x by its value and we're going to simplify it. Alright, so now, after substituting the value of x, then we evaluate and simplify this. So this will become 0 minus 7. You have negative 7 all over 0 plus 3, which is equal to 3. Now, the limit of this function as your x approaches 0 is negative 7 over 3. All right. So let's have another example in number 2. All right. So we have here, we're going to get the limit of your x squared minus 4 all over x minus 2 as your x approaches the value. Let's say, let's use 2. All right. We have here this, again, rational function. So let's apply the substitution method here. So we will have here the square of 2 minus 4 all over 2 minus 2. All right. So as you can see, if we simplify this, this will become the square of 2, which is 4 minus 4 and 2 minus 2. And if you simplify this, you will have an answer of 0 over 0, which is in determinate form. All right. So there are some cases when after applying the substitution method, the answer would end up in the form 0 over 0, which is indeterminate. All right. Now, there are two ways to evaluate the limit of these types of function. And we can do the factoring method, factoring, or the conjugate method. All right. Now, let's do the factoring method. If we apply the substitution rule and we end up with the answer in the form 0 over 0, which is indeterminate, then the next thing that we have to do is to do the factoring method. We have to factor the numerator or the denominator to the point that we can eliminate the common factors between those two. All right. So the first thing that you have to do is to try to think of what are the common factors between this numerator and denominator. And as you can see in the numerator, it is a difference of two squares that can be factored or can be expressed as the product of their factors, which is x plus 2 and x minus 2. All right, so let's put here the limit as your x approaches 2 all over x minus 2. And as you can see, the numerator and the denominator has common factors, which is x minus 2 and x minus 2. And we can simply eliminate this 2, all right? And this will be equal to 1. So we have here the limit of your x plus 2 as your x approaches the value 2. So now we have here the limit. And what will be the limit of this? By applying the substitution method again, so we evaluate this function. We have here the limit of your 2 plus 2, which is equal to 4. Alright? So sir, bakit hindi po conjugate ang ginamit natin? Now, we can't use the conjugate here because it will just make things more complicated. If we use the conjugate, make sure there is a radical in your function. So let's have another example where we have a radical. Let's say you're going to get the limit of x minus 9 all over square root of x minus 3 as your x approaches 9. So before anything else, let's try to apply the substitution method here. So we have here 9. The limit of this function will be equal to 9 minus 9 all over the square root of 9 minus 3. All right. And we simplify this one. We have here 0 all over the square root of 9, which is equal to 3 minus 3. We also ended up with 0 here, and which is indeterminate. We all know that it is indeterminate. So in order for us to uh, simplify this, or in order for us to get the limit of this function, we have to use the conjugate method. And let us know how can we use the conjugate method here. There are cases where your rational function involves a radical, all right? And after using substitution rule, the result is 0 over 0, and this time we have to use the conjugate method. Because if you use the factoring method, it will just make the things more complicated, all right? So in order for us to use this method, we define the conjugate as the conjugate of any binomial that is in the form of a plus b is a minus b. All right. So if you're going to get the conjugate of any binomial in the form a minus b, the conjugate of this is in the form a plus b. All right. So when we say conjugate, you're just getting the opposite operation of these two binomial. All right. So if we have here the rational function, we have to identify the expression with a radical and determine its conjugate. All right. So we have here the square root of x minus 3. We have to get the conjugate of this by applying this. If you have here in the form a minus b, so the conjugate of this should be in the form a plus b. So we have here the square root of x plus 3 and multiplied by square root of x plus 3. As you can see, we're just multiplying this expression by 1, but using the conjugate of this expression with a radical. And we're going to try to eliminate the factors on both numerator and denominator. All right, so let's see. If we multiply these two, we are going to get the product of x minus 9 times square root of x plus 3 as x approaches 9 all over multiply this one. As you notice, these two are very familiar. It is in the form of the sum and difference of a binomial. And if we multiply this will be equal to the difference of two squares, which is the x square root of x squared minus the square of 3, which is equal to x minus 9. And as you can see here, we have here the common factors that can we eliminate. And we have here, if we eliminate this, we will have the limit of the square root of x plus 3 as your x approaches 9. So in here, we can simply use the substitution method for us to get the limit of this function. So this will become the square root of 9 plus 3, which is equal to 3 plus 3. And the limit of this is simply 6. All right. So if you want more examples regarding the substitution method with cases where you have to use the factoring method and the conjugate method, you may refer to the examples that is given in your module. All right. So have a mathful learning and see you next video.